Alright, welcome to episode 11, what I'm going to call Keep the Chain Going. I'm Reed Evans and I'm on Twitter at ReedNEvans. So keep the chain going. So sometimes when you're trying to compose a bunch of stuff together, what you end up with is a function that doesn't return anything. And if a function doesn't return anything, then the result of that can't be piped into the next function that needs it or returned as output or whatever else. Now, of course, the only time that you should probably have a function that doesn't return anything is if it's performing some sort of side effect, because if a function doesn't return anything to you, and it doesn't perform a side effect, then there was no point in calling that function. So we've got some code here, and it's just broken out. One of the things I'm kind of mocking out here is the concept of an HTTP post, but basically we're giving it an endpoint and something for the body, and we're going to return a future. Which is coming from ramda-fantasy in this case, and we're just going to mock out the fact that it's a future. So we're returning a future. We're not doing a promise because a future is pure and a promise is not, because a future is not actually going to do anything here. We have to actually call another method to be able to make that work. One of the other things we're going to do is we're going to simulate local storage here, and we've got our I/O. So here is our function that were it not wrapped in I/O, we'd give it a string and it would just, set that storage. It's a command, it's not a query, so it doesn't actually return anything. We're going to wrap it in I/O though, so it does actually return an I/O, and essentially it makes this lazy. And so what we want to do is we want to be able to create, in this case, and authenticate, and I've got FIO to here just as some Hungarian notation to say that it's returning a future of an I/O of something. So it's going to take a login object, whatever that is, and it's going to return a future of either an error or, in this case, an I/O, which contains the string. So what we're going to do is we're going to do this HTTP post F, and we're going to partially apply the authentication, which is the URL, which means that essentially it's going to take our login object, which in this case we're just going to pass a token. But then we want to compose that together with the get token and save IO. So what does get token and save IO do? It takes some object that has a property of token, and then what we want to do is we want to set the IO. So we want to store it in local storage, but then we also want to have it. We want to return that value too, and that's when I've wrapped it in this T function, and that's really what I want to talk to you about today. Is the T function. So that's where we've gotten all the way down into here. So now we're in this T function. So what does the T function do? Well, it's going to take some functor of F. Right? It doesn't matter which functor. Right? So a functor is something, the TLDR version of that is something that can be mapped. We're going to have, as our first argument, something that takes some value into some A and returns a functor of it. Technically this could be something, it could be nothing, it could be whatever. So it could be a dead end function here, but it's a functor, whatever that functor is, of some value or of nothing. In this case it'll be nothing, and we're going to end up passing an IO of nothing to it, or unit. You might hear that called in functional programming terms. And then what we want to do, and then we're going to take the A that would be passed into that function, and we're going to return f of A. So what that ends up looking like is curry, we're taking a function that accepts an A, we're accepting an A, we're applying A to the function, and we're going to map over that, and then what we're end up going to return then is that functor, because it's a map, and we're going to return A inside of it. What that allows us to do now is we don't have a dead-end function anymore. We called our dead-end function right here, and then we then mapped over it to then end up returning the A that we passed in for here. So I'm calling it T. That's coming from Scott Voloshin with his railway-oriented programming. I guess he came up with the term. I don't know. There may be an actual Haskell-approved term for that, or category theory-approved term for that. But anyway, what you see is that if we get the prop token and then pass that into the T of the set IO, and then we'll be getting the token and saving the IO. So let's see how this all works. The proof is in the thing running. So obviously everything below here is going to be our impure code. And what we want to do is we want to say that we're going to, we have our result, right? Which we're impure, so we're at the boundary. So we're going to call the authenticate IO, we're going to pass the token into it. We're going to fork, which is actually going to run the future. We've got to deal with our error case. And we're also, because authenticate FIO returns a future of an IO, then the success case is going to contain an IO, and we can set result to IO run IO. So it's kind of a way of, at the boundary, dealing with multiple of those things. So what do we get if we then say result? So you see, get ASDF, which is what we passed in. That's what's coming out. But we can also check to see what storage was. Storage, we actually did update our, our local storage here to say that key was ASDF. So if we hadn't had this T, this whole thing would have returned an IO of unit rather than IO of string. But this T allows us to basically take the result from this, perform this operation, and then take the result of this and stuff it in the same context, the same functor that was returned by set IO. So anyway, hopefully that helps. Hopefully that was not too complex, but it was a way, example of seeing, in this case, writing this small little function here that works for any functor to allow us to continue chaining through stuff. This has been episode 11. Keep the chain going. Thank you very much.